Hello students, welcome to the lecture. The topic that we are going to cover today is minimum and maximum speed with which the vehicle can move on a rough banked road. So in the last lecture, we derived the formula for angle of banking, and the formula was tan theta is equal to v square by rg. When we derived that formula, we did not consider friction, but here we are going to consider friction. So when we did not consider friction, the formula for angle of banking was tan theta is equal to v square by rg. And by rearranging that formula, we can get the speed as under root rg tan theta. Now this is the speed with which the vehicle moves on a smooth banked road. But it is beneficial to involve friction in our calculations because we know that the friction will help us in turning on circular roads. So if it's possible, we should involve friction. Now, when we involve friction, we get two limiting speeds. First is V minimum and the second is V maximum. Why do we have V minimum? Because below the speed, when we go below V minimum, the vehicle skids downwards on the banked road, which means if the velocity of the vehicle or the speed of the vehicle is below the minimum permissible speed, then there is a tendency of the vehicle to slip downwards on the banked road. The another limiting speed that we have is Vmax. Now, why do we have it? Why do we have this limiting speed? Because if the speed of the vehicle becomes more than Vmax, then the tendency of the vehicle is to be thrown outwards on the banked road. So when V is greater than Vmax, the vehicle is thrown outwards on the banked road. Therefore, we have two limiting speeds. First is V minimum and the second is V maximum. If V is less than V minimum, then the vehicle will skid downwards on the banked road. And if V is greater than V max, then the vehicle will be thrown outwards on the banked road. Okay. The first derivation that we are going to see is for the minimum safe speed, which is V minimum. Now, in this case, as we discussed, that when the velocity or the speed becomes less than V minimum, the tendency of the vehicle is to slip downwards. The tendency of the vehicle is to slip downwards. And to avoid this downward slipping, the Fs, that is the static friction force, must act outwards. Therefore, Fs acts outwards. Now, if you have a look at the diagram, we can clearly see that a combination of n sine theta and negative Fs cos theta will provide us the necessary centripetal force. Therefore, using this information, we can write down mv square by r is equal to n sine theta minus Fs cos theta. So this is the first equation that we get by basically using the information that the centripetal force will be provided by a combination of n sine theta and negative Fs cos theta, as they can be seen to be acting towards the center of the circular road. Then we can clearly see that the vertical forces n sine theta and Fs sine theta, n cos theta and Fs sine theta balance weight. So we can write down mg is equal to n cos theta plus Fs sine theta. This is the second equation that we get, which we can use for the derivation of the minimum speed. So I have written down the two equations that we can use for the derivation, which is mv square by r is n sine theta minus Fs cos theta, and mg is equal to n cos theta plus Fs sine theta. So we basically do nothing but divide the first equation by the second equation. So mv square by r upon mg is equal to n sine theta minus Fs cos theta upon n cos theta plus Fs sine theta. M and M gets cancelled, and we have V square upon Rg is equal to n sine theta minus Fs cos theta upon n cos theta plus Fs sine theta. Now, let's understand what happens at minimum speed. So as we discussed, at minimum speed, the tendency, or below the minimum speed, the tendency of the vehicle is to skid downwards on the banked road. And we have to avoid that skidding, which is done by using the friction force acting upwards on the banked road. So when V goes to V minimum and we have to avoid the skidding, the static friction applies its maximum effort to stop the vehicle skidding downwards. Therefore, we can say that when V goes to V minimum, the static friction applies its maximum effort, which means that the static friction has its maximum value equal to mu s n. So by putting these values into the equation, let's plug these values into the equation and let's see what do we get. So V goes to V minimum square upon Rg. V minimum square upon Rg is equal to n sine theta minus, in the place of Fs we write mu s n. So mu s n cos theta divided by n cos theta plus Fs sine, plus mu s n sine theta. We can common out n and cancel it from everywhere. And finally what do we get is V minimum square upon Rg. So over here in the equation just above, I have not cancelled singular n's. I have first taken the n common and then I have cancelled. Okay, good. So V minimum square upon Rg is equal to sine theta minus mu s cos theta upon cos theta plus mu s sine theta. Okay, so this was the last equation that we had got. Now let's simplify this further. What we do is we divide the equation by cos theta, both numerator and denominator on right hand side. So let's do that. So we have V minimum square upon Rg is equal to sine theta minus mu s cos theta upon tan theta, upon cos theta, the whole thing divided by cos theta plus mu s sine theta upon cos theta. Now if we simplify this, sine over cos is tan, cos and cos gets cancelled, so we have mu s, cos and cos gets cancelled, so again we have 1 plus mu s into sine over cos is tan. So finally we have an equation for the minimum speed, which is nothing but under root, the Rg goes over other side, into tan theta minus mu s upon 1 plus mu s tan theta. So this is the equation for the minimum speed with which the vehicle can move on a rough banked road. If the speed goes below this minimum speed, then the tendency of the vehicle is to skid downwards onto the banked road. Okay, let's move on to the next topic, that is nothing but the maximum speed or the maximum safe speed, which we call Vmax. Now, when the vehicle travels at maximum speed, as we have discussed, that the tendency of the vehicle is to be thrown outwards on the banked road. And to avoid this outward throwing tendency of the vehicle, the friction force must act inwards so that the vehicle will not be thrown outwards. So we can see that the friction force is acting inwards over here. Now, as we can see from the diagram, that a combination of n sine theta and positive Fs cos theta now provides the necessary centripetal force as they are acting towards the center. So we can write down mv square by r is equal to n sine theta plus Fs cos theta. So this is the first equation that we have. If you look at the vertical forces, we can see that n cos theta is balanced by Fs sine theta and mg. N cos theta is balanced by Fs sine theta and mg. And therefore we can write down mg is equal to n cos theta minus Fs sine theta. This is the second equation. So we have two equations with us. Let's solve them and reach at the formula for maximum safe speed. Okay, so at the top we have the two equations which we have to solve to reach at the result. So let's solve them. So first what we will do is divide equation 1 by 2. So mv square by r upon mg is equal to n sine theta plus Fs cos theta upon n cos theta minus fs sin theta. M and M gets cancelled. So we have v square upon rg is equal to n sin theta plus fs cos theta upon n cos theta minus fs sin theta. Now we use the fact that when the vehicle is traveling with the maximum speed, the friction force applies its maximum effort to avoid the tendency of the vehicle to be thrown outwards. So when V tends to V max, the Fs must tends to Fs max. So the friction must apply the maximum effort that is possible to it so that it will avoid the vehicle from getting thrown outwards. So in place of V, when we substitute V max square over Rg, we get it as n sin theta plus, in the place of Fs, we write mu as n cos theta upon n cos theta minus mu as n sin theta. Now again, first we take the n common and then cancel out. So first common out n from numerator as well as denominator and then cancel n. So let's do that. So I'll not do the step. I have commoned out the n and then I've cancelled. So I have V max square upon Rg as sin theta plus mu s cos theta upon cos theta minus mu s sin theta. Again, if I divide the right hand side of this equation completely by cos theta, I am going to get V max square upon Rg is equal to sin upon cos is tan. Then cos and cos gets cancelled, I get mu s. Again cos and cos gets cancelled, I get 1. And then sin over cos is tan. So finally, what I get is the maximum safe speed with which the vehicle can travel on the rough bank road is nothing but under root Rg into tan theta plus mu s upon 1 minus mu s tan theta. So let's finally compare both the speeds, V minimum and V maximum. So the formula for V minimum was under root Rg tan theta minus mu s upon 1 plus mu s tan theta. And the formula for V max, I'll write it down again, is under root Rg into tan theta plus mu s upon 1 minus mu s tan theta. So if you know the formula for minimum safe speed, then just replace the negatives by the positives and the positives by the negatives. So in the place of minus, we should put plus, and in the place of plus, if we put minus, we can switch from the formula for minimum safe speed to the formula for maximum safe speed. So here are the two formulas, and thank you very much.